All right. Hey guys. So we are going to extend our discussion that we did last week and kind of do the same process, but I'm going to leave a little bit more in your hands. Now, to refresh your memory, ooh, by the way, I'm looking at my I went and found my jacket. Very, very sciencey here. I like it. I don't actually need these, but they're cool. I'm going to wear them. All right. So to refresh your memory, what we did last week, and I still have this stuff sitting out here, we measured the mass and volume of a bunch of samples of water, and we graphed the stuff up, and we kind of alluded to this idea of density a little bit, and the slope of the line was kind of density. And I want to introduce another term, and that term is intrinsic property of matter. An intrinsic property of matter is a property of a substance that is not going to change if you change the mass or the volume. Okay. For example, I've got the little base of my graduated cylinder here, and I bet it's red all the way through. So an intrinsic property of this piece of plastic is that it's red. All right. Density is also an intrinsic property of matter. So the density of water, based on last week's lab, seems to be about 1 gram per milliliter. It doesn't matter if we have, a big sample or a little tiny sample. The density of both of those waters is equal to basically 1. So what we're going to do today is a similar setup, but instead of using water, we're going to use 91% isopropanol from my friends at the Walmart, the river from whence all good things flow. Okay. So we're going to do this in a couple of steps. I'm going to have you guys actually do more of this on your own because I want you guys to think about lab processes. And let's go ahead and get started. So just to be a little different, we're going to do 4 objects following the same pattern that we did last week. I've got a 25 milliliter graduated cylinder. I've got some sort of weird votive candle holder. I don't know why this was in the classroom, but it was. We're going to do a little plastic bottle. And what else do I got here? We can do a beaker. Okay, so I'm going to move my camera off of my face and down to my chest so you guys can see what we got here. So we've got 25 milliliter graduated cylinder. We've got candle holder cup thing. We've got plastic bottle, and we've got beaker. So here's what I want you guys to do first. Then I'm going to have you stop the video here in a second. I want you to grab a piece of paper. It can either be lined paper or printer paper. And I want you to turn it to landscape. And I want you to make a data table of what you think we're going to need. What data are we going to need to do the same process that we did last week? So instead of me giving you the data table, I want you to just make a data table. And I want you to stop the video, and I want you to make a data table, and then I want you to start the video back up. All right? So 5, 4, 3, 2, 1. Okay. People are back with me here. All right. Here is the data table that I came up with. Okay. It doesn't need to be fancy. You guys are going to turn it in, but we're just getting data, so it doesn't need to be fancy. I've got object, and I've got 4 objects. So we've got 1, 2, 3, 4. Now, pay super close attention. So I've got mass of the object, and notice that I put the unit in there. The unit is going to be in grams. And I've got the mass with alcohol, so I'm going to measure the mass of the empty object and then the mass of the alcohol. And I'm also going to do that with grams, because when we record data, we should include the unit. Grams is called the unit. We're eventually going to calculate the mass of the alcohol, and that's also going to be in grams. And we're going to measure the milliliters. Okay? So we've got object, grams, 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 milliliters. Now, if yours doesn't look like that, you should probably make it look like mine, because that's how I'm going to record the data. All right, so if you need to change it, go ahead and change it and then restart the video. 5, 4, 3, 2, 1. All righty. So I think that I am going to need a reservoir for my alcohol. So let's have this go away. Need another place to put this so it's empty. Should have thought this one through better. All right, go there, because I want to be able to pour this stuff back in there. So we're just going to get plenty of alcohol to do the thing. Now, first things first, you don't need to write this down, but I want you to think about what you might actually know about the world. 91% alcohol, 10% water. If the density of water is about 1.0 grams per milliliter, is the density of alcohol greater than or less than water? You don't need to know, but maybe you do. Is the density of alcohol more or less than water? All right, so just think about that in your head, and let's get started. All right, we can do this in any particular order we want. It doesn't really matter. So I'm just going to grab the 25 milliliter graduated cylinder. So let's do 25 milliliter graduated cylinder, and I'm going to cheat, and I'm going to write GC, 25 milliliter graduated cylinder. Okay. I'm going to put that on my balance, and that has a mass of 44.54. So the mass of empty is 44.54. All right. And now I'm going to add alcohol basically to the top. And I just realized something. I'm going to need to pour the stuff out of my graduated cylinder. Okay. 69.92. So we go up to 69.92. And we're going to calculate this guy here in a minute. So we're not going to worry about that. And now we want to measure the volume. And because Mr. Shoot's getting a little old, he forgets things. So I got to go empty this guy out. I'll be right back. All right, so now we've got an empty graduated cylinder. Get that really good and empty. And the volume is 31.5 milliliters. All right, 31.5. So there is our first set of data. I don't need to write milliliters here. If we want to be super duper fancy, we could. I could put milliliters there, but because I already put it up at the top of the column, I don't need to do that. So we've done our 25 milliliter graduated cylinder. Let's go ahead and do our little plastic flask. So I'm going to do plastic flask. Cool. Okay, that has a mass of 9.48 grams. That seems to actually hold more than the 25 milliliter graduated cylinder. The reason why I'm using this guy is it's just easier to pour from. All right, so we basically filled that guy up. So let's put that on there. That is 58.98. 58.98. Empty that guy back into there so we can get the volume. And that is 61.5. All right. 61.5. All right. Next thing, we'll do the candle cup. We'll call that the candle cup. Yep. The candle cup weighs 65.02. And let's fill that guy up. And that is 154.47. 154.47. Ooh, I gotta pour that back into the graduated cylinder. Good thing I kept my funnel around. All right, this is gonna be a little tricky. So similar to what we did last time, let's fill it up below the bottom of the funnel. That is 68.0. So we're going to do two measurements here. 68.0. And 43.5. 68.0 plus 43.5. All righty. And then you go there. And then finally, our last guy is our beaker. So we're going to do four guys. The last one is beaker, B-E-A-K-E-R. Beaker. All right, beaker weighs remember I said last week, even though it's incorrect to say weight, it's just a term everybody uses, has a mass of 29.82. Fill it up to the top here, ish. And it goes up to 76.56. And we have a volume of 58.7. 58.7 milliliters. All right. I think we got the data that we need. So here's what I want you guys to do. I put some graph paper up on Schoology if you want to print it out, or if you have some, or if you want to make some on a piece of notebook paper, but be reasonably accurate. I'm going to have you guys do 3 things in 20 minutes, then we're all going to come back into the meeting. So thing number 1, I want you to calculate the mass of the alcohol. ALCOHOL. Hey, I spelled that correctly. All right, so calculate the mass of the alcohol. 2, I want you to make a graph of volume of alcohol versus mass of the alcohol, where you have mass on the Y and volume on the X. Okay? And then the third thing I want you to do, sorry about that, is I want you to determine the density of the alcohol mix. It's actually an alcohol water mix, but determine the density of the liquid inside of there. And even if you don't know how to do all of this, you should be able to do some of this. And so we'll come back together in 15, 20 minutes, and we will debrief this. And I will be on the call if you have any questions.